In this video, we want to solve the differential equation x squared times y double prime plus 3xy prime equals 2. So let's make a substitution. We're going to let v equal y prime. So dv over dx is y double prime, because the derivative of y prime is just y double prime. And now we can replace y double prime and y prime with dv over dx and v. So we have x squared dv over dx plus 3xv equals 2. And now we're going to divide both sides by x squared. And the reason I want that is because the coefficient of dv over dx has to be 1. And on the right side is a function of x. So we need to use an integration factor. And that's going to be 3 over x, which is a coefficient of v. So we'll do e to the integral 3 over x, which is e times 3 to the ln of x, and that's just x cubed. Okay. So one way to rewrite this, I guess we can have an intermediate step if you want, and say e to the ln of x cubed, and then e and the ln cancel, and we're just left with x cubed. So we're going to multiply now by our integration factor of x cubed, both sides. So you distribute the x cubed to all three pieces. So we get dv over dx times x cubed plus 3vx squared equals 2x. And now notice the derivative of x cubed is 3x squared, and the derivative of v is dv over dx. So this is, in other words, the product rule for x cubed times v. So we write this in derivative form. So the derivative of x cubed times v is equal to 2x. Now we have to undo this derivative by doing the antiderivative to both sides. So when you do that, the derivative and the integral will cancel. You have x cubed v, antiderivative 2x is x squared, and then we're going to also add a constant. Solving for v, we divide both sides by x cubed, and recall that v was y prime. So now we can find or do the integral both sides. So the integral and the derivative are going to cancel, so we're left with y. Antiderivative 1 over x is ln of x. Antiderivative of c1 over x cubed is negative c1 over 2x squared. And then don't forget to add another constant. Now we have negative c1 over 2. That's really just another constant. You take a constant divided by 2, you still have a constant. So now I just called it c1 over x squared. And so this is my solution to the differential equation.